currently works. And a lot of people who want to change the energy system have no idea at all of how it works. And so they can do great damage if they do the wrong sort of thing.
Well, in reading your book, one of the things that became very clear is there's so much data to sort through. It's incredibly complex. I actually listened to it on audio, and there were sections of it where I had to go back over it again just to try to wrap my head exactly around what was happening. To squash some more of the criticism really clearly up front, you're very clear about this. You believe the climate is changing.
Climate is changing.
You
Absolutely.
believe that human beings are having an effect.
They are influencing those changes, yes. Absolutely. Mostly through greenhouse gases that are accumulating in the atmosphere. Absolutely.
Your position, though, is that there's either an exaggeration or there's a way that people are looking at the data that's alarmist that you don't think is reflected by the actual numbers themselves.
Yeah, that's correct. I think that, to put it in a British sense, they have over-egged the custard.
Now, why do you think this has happened?
I have in the book one of my favorite quotes from H.L. Mencken is the purpose of practical politics is to keep people alarmed by a series of mostly imaginary hobgoblins so that they can be clamoring to be led to safety.
Now, if you think that human beings are affecting the climate and you think the climate is changing, what percentage of an effect are human influences?
Yeah, so, I think we don't really know that. The UN Intergovernmental Panel on Climate Change in its last report in August said, it's all human-caused in the last many decades.
All of it.
All of it. But, they completely forget that the climate was changing in comparable ways well before human influences became important. And so they say, no, we're going to ignore that, we're going to suppress it, and say it's all human-caused.
Now, one of the things you highlight in your book is that when you're looking at the way the temperatures have risen on Earth over a period of, say, like 100 years, that if you do it in these blocks of time, that there's a way to look at it in a deceptive way that makes it seem, in the alarmist way, where it makes it seem that radical drastic change is happening over a very short period of time. That's all I've ever heard.
Yeah, so, the climate changes a lot on its own. Maybe we can put up a picture, which is one of the ones I wanted to show you. Can we put up the second chart in that file called Kunin Thumbs? And what I'm going to show you is a record of the height of the Nile River, which has been compiled by the Egyptians. We'll go to the next, there we go. Height of the Nile River from 640 AD up until 1450 AD. So about 800 years of data every year about what was the lowest level that the Nile River reached in that year. The Nile was important to the Egyptians, as you might imagine, and so they measured it pretty carefully. And what you see are two things. The blue spikes are the annual values. They go up and down a lot. One year it was up at 6 meters, 20 feet, and then the next year it was down to 1 meter or something like that. So a lot of variability from year to year. But then if you look at the curve, which is the average trend over 30 years, you can see, for example, in the first 100 years, it was going down. And you can imagine some medieval Egyptian climate panel saying, new normal, new normal. We've got to do prayers and sacrifices. And of course, if they just waited another 100 years, it came back up again. And this was all before humans had any influence on the climate.
Are we looking at climate and we're looking at these periods of time, are we looking at them incorrectly because we have such a short lifespan ourselves that we tend to think of great change as happening in these incremental ups and downs, but realistically we should be looking at it on a broad, long spectrum of hundreds, if not thousands of years?
Yes. So climate changes on all time scales. It changes on 1,000-year timescales, it changes on 10,000-year timescales, and it changes on decades. Every decade it changes. And we also forget a lot. In the Midwest, there was a drought in 1955, and one of the news magazines, Time magazine, said, "This drought will be long remembered." Nobody remembers 1955 drought anymore. So we forget, and we think things are unprecedented when in fact they have happened before.
Now, you are, by training, you're a physicist, correct?
Correct.
And another criticism would be that you're not a climate scientist. People will say that. Now, my question, though, and I think you'd probably be able to help me on this, is like, what exactly is a climate scientist? Because most science, you have a hypothesis, you run tests, you get results, and then you do these experiments, and that's how you get your data. With climate science, is it based off models?
Climate science is a very integrative discipline. It involves physics, chemistry, biology, geology, statistics, computer modeling, and so on. So nobody can be an expert in everything. Many prominent climate scientists are trained as physicists. Look at Jim Hansen, Michael Mann. Michael Mann actually once applied to be my graduate student. And, he decided to go to Yale instead, but that's a different discussion. That was many decades ago. And so some of it is certainly physics. I have published in physics about climate science. I published a paper in August where we were watching the moon for 20 years to learn how shiny the Earth was. That's very important because if the Earth gets less shiny, it absorbs more sunlight and so gets warmer. And we published a paper and it attracted some attention, press releases and so on. So I have published in climate science. But more importantly, the kind of things I point out in the book are obvious to anybody who has any quantitative sense at all. It's like, if I were ordering carpet for a room and the room was 8 by 10, I would need 80 square feet of carpet. If the carpet guy comes back and says you need 400 square feet, I'm going to ask him some hard questions. Right? And that's the kind of misleading things that I'm pointing out in the book.
How did you get started on this journey of being, I want to say obsessed, but if not fascinated with the science of climate change and the data itself?
So I was exposed to climate science in the early 90s when I was working with a group called JASON, which we can talk about at some point, for the government and looking at the impact of then high-performance computing and small satellites on climate science.
And the group JASON is top scientists in their field that are recruited to work for the U.S. government. And it's like, 70% of it is classified projects?
Yeah, something like that. We work for all government agencies, but a lot of what we do is for the national security parts of the government.
And it's tackling the most complex,
difficult,
scientific,
technical problems, sometimes mysteries that the government finds going on in other countries, things of that sort, what's going on, et cetera. Or how do we do X, Y, or Z technically?
And so what was the initial study that you had read, or what?
Yeah. So the initial thing that got me interested was the Department of Energy wanted to deploy a fleet of small satellites, which, remember, this was 30 years ago, so that was a pretty big, innovative deal, to look at the Earth and monitor what was going on for climate purposes, for science. And one of the things that you could do was to measure how shiny the Earth was. The albedo, it's called technically, whiteness of the Earth. And, of course, being curious, we asked the question, well, how was the albedo first measured? And the answer was, back in the 30s, some guy started watching the dark part of the moon. And that brightness of the dark part of the moon is lit by light that is reflected from the Earth, and so is a good measure of how shiny the Earth is. It hadn't been done for 30 or 40 years, and so we started up a program that continues to this day to watch the dark part of the moon to monitor how bright the Earth is. And we just published a paper in August that showed the Earth has gotten a little bit dimmer over the last many years, and so not surprising, it perhaps gotten warmer. Anyway, that sort of got me interested in climate science. When I moved into the private sector, I was more concerned with energy technologies and how we could develop and deploy or demonstrate and deploy technologies that would reduce greenhouse gas emissions. And I did that for quite a while in both BP and then in the government. And then in 2014, the American Physical Society asked me to do a review of their statement about climate science. They had put out a statement in 2007, which was very controversial among the physicists because it used the word incontrovertible. And for a physicist, that's fighting words. Okay? So they asked me, Steve, recommend a new statement. And so I said, heck, we're physicists. We're not going to take anybody's word for it. Let's look at the issue ourselves. And so I convened a one-day meeting with 3 mainstream climate scientists and 3 credentialed skeptical scientists. And we sat for a day, presentations, talk, discussion, in early 2014. It's all up on the web. It was transcribed. You can find the transcript. And I came away from that thinking, this science is not anywhere near as settled as I thought it was. Because of the problems with the models, the observational data, and so on. And my little group wound up proposing a statement that could not get through the bigger committee that was approving such things. People would say things like, we can't say that even if it's true because it gives ammunition to the deniers.
Really?
And, yeah. Yep.
Now, how frustrating, as a scientist,
Well,
how frustrating is that?
I got so frustrated because I'm used to, through Jason and others, of giving advice to decision makers. You play it straight. You say, this could be, this may not be, here are the options, and so on. But you don't try to spin the advice to get one answer or another. And I was really annoyed by that. I wound up resigning from the committee, but I wound up then publishing an op-ed in the Wall Street Journal. They gave me 2,000 words, which was great. We got a couple of thousand online comments. Many people said, thanks for writing this and trying to expose the real science to what's going on. Of course, the establishment trashed me completely, even though I was just repeating what's actually in the reports and in the research.
And what was the nature of their criticisms when they trashed you?
Oh, you're cherry, and we get it to this day with the book. You're cherry picked, you're misleading, what you said is actually not true, and so on, even though I point to, chapter and verse in the reports where these things are said.
So is this, are the scientists that are claiming you're cherry picking, are they signaling to the other people that follow the ideology that you're not to question climate change, and that anything that you say that in any way calls doubt to the settling of the data gives some sort of ammunition to the people who are the real climate deniers, who are a real problem?
Yes, indeed.
Yeah.
And look, my sense is that this is a problem. It's not an existential threat by any means, and it's a problem that we have time to deal with, and we should deal with it in time in a graceful way. But I think, when the book first came out, there appeared an article in Scientific American written by, I think, 13 mainstream climate scientists that was a couple thousand words of mostly ad hominem criticisms, a couple of substantive criticisms, which I have rebutted, I think, quite effectively. But it put a marker in the ground that people who didn't want to have the book understood could point to and said, aha, those guys said Kunin's an idiot.
Now, what criticisms made sense that you could rebut?
Well, they said, for example, I said sea level rise was not accelerating. And of course, I got a whole chapter that talks about the ups and downs of sea level rise. But they would criticize a review of what I said by somebody else, or they would say sometimes, Kunin said that, and it's true, but it's not important because of A, B, and C.
If you don't mind, pull that microphone just a little closer to your face. There
Sure,
you go.
how's that?
Perfect.
Right.
Now, so these criticisms that were levied against you, did anyone of prominence that is a climate scientist come out and say, this is a very interesting analysis of the data, these are things that I hadn't considered, Koonin makes a lot of really good points?
Not in public.
Not in public.
Not in public, in private. You know, when I first sort of came out in that Wall Street op-ed in 2014, I had a chat afterward with the chair of a very prominent earth science department at one of our best universities. I won't say who or where, but suffice it to say, it's somebody who is firmly in the business. And he said, you know, Steve, I agree with almost everything you said, but I don't dare say it in public.
Wow.
All right? You know, there's a whole organization called Covering Climate Now, which is a consortium of media, including the BBC and NPR, I think, and so on, who have, you can look them up on the web, and they have signed an agreement or made an agreement that they will not cover anything that diverges from the narrative.
And who establishes the narrative? Like, what's the top of the heap?
I think, you know, the allegedly authoritative voices are the UN Intergovernmental Panel on Climate Change, IPCC, which issues reports, major reports every 6 or 7 years. There is the U.S. National Academies of Science. There is the UK Royal Society, and the U.S. government issues reports as well. And, you know, when you get into the meat of these reports, they have some problems, and you know, we can go into them, but by and large, they're pretty good summaries of the science. But when you get to the summaries for policymakers, or you get to the media coverage or the political discussion, that's where things get really corrupted. So it's like a long game of telephone that starts with the basic science, and the scientists doing it are by and large, you know, good, honest, hardworking people, and you talk to them privately and they'll admit to all the problems that they've got. But by the time it gets to the end and the public, it's, you know, the science is settled, we're headed for doom, et cetera, et cetera.
Well, that's always the case with something that's really controversial, right? There's always the alarmist perspective and the people that are looking at it that have maybe a less extreme point of view are criticized because they're not taking it seriously enough. And then there's what you were saying earlier, is that people are saying that, like, they can't even say certain things because it will give ammunition to the people that are real climate skeptics.
Right.
The people that aren't paying attention to the science, that have an ideology or a dogma that goes in the other direction.
Yeah. There's so much analogy here with the Reformation, when the Catholic Church started to come at odds with the Protestant movement. Let me give you two examples. In one of the best recent introductions I've had, you know, I'm a humble guy and I usually like to keep the introduction short, but this one was real interesting. I was compared to William Tyndall. Now, I didn't know who William Tyndall was. I'm not a historian, so I had to look up. William Tyndall, in the early 16th century, did one of the first translations of the Bible from the original Greek and Hebrew into English. So it had been originally in Latin, and so that let ordinary people read what was in the Bible. And of course, the establishment got really mad at him for doing that. He was eventually burned at the stake for that and other reasons. So, you know, I sort of made these reports accessible, at least parts of it, to ordinary non-experts. So that's one. The other one, which is maybe even more amusing, a couple years ago, 13 senators, led by Mr. Schumer, proposed a bill that says the government may not spend any money to challenge the consensus. The Council of Trent in the early 16th century said very much the same thing about church dogma, not about spending money, but you know, you'd be in all sorts of trouble if you challenged dogma.
What would possibly motivate the government to come out with a statement like that they can't spend any money to challenge the consensus? And doesn't a consensus mean most? It doesn't mean all.
All, right.
So in cases of dogmatic opinions or ideologically formulated opinions,
You know, I'm so surprised that the government would try to suppress the scientific process like that. I think what precipitated it was I had, for a number of years, been advocating for a red team review of climate reports. Now, where you get a bunch of credentialed people to look at the report and ask, what's wrong with this? We do that kind of thing all the time for spacecraft, other matters of consequence when we have to make judgments. And I almost got to the point where we could have pulled it off, but the Trump administration in the end decided they wouldn't do it.
Now, the Trump administration had some of its own problems with climate science in the wrong way, correct?
Absolutely, absolutely. I felt I was, of course, a little bit concerned about going through the administration, but I had lined up the national academies to play the blue team. I had assembled pretty much a good red team, and then it was stopped at the last minute by a political decision. So I'm really disappointed because I point out in the book a lot of problems with those reports. It says X, but in fact the truth is Y if you look at the data. So we need that. It's about the integrity of the scientific institutions.
So let's go back to your initial impression that the science was not settled. When you first walked away from this meeting that you were discussing, and you realized that this is either far more complex or it's influenced in a way where it's not just about the data, it's about what the narrative is. So how do you go from there before you write this book? Like, what are your next steps?
So I started paying more attention to the disconnect between what was actually in the science versus what was either in the reports or in the political dialogue. I think the next turning point came when I was helping with a study for another government agency and had occasion to look at hurricanes. And I turned to the official U.S. government report in 2014 at the time, and you see this graph in the body of the report of some property of hurricanes going through the roof over the last 30 years. And it sure looks like, if you look at that graph, we're in trouble. And so I dig a little deeper. I look up the reference that they cite, and I read in the back of the same report on page 700 and something, if I remember right. And it says there are no long-term trends in hurricanes, okay, which is still largely a true statement, all right? And I'm looking at that, and I said, my God, that's a swindle. In the part of the report that everybody's going to read, you see this graph going up, and it looks like all hell is going to break loose. And then in the back, it says we don't see any long-term trends.
So what is the graph? Like, what is the data?
So the graph is basically a graph. It's called the Power Dissipation Index, which is a graph of how many storms and how intense they are over the last 40 years.
And what is the trend?
Well, in that particular case, it was going up, okay, from 1980 up until 2010. But what they didn't show you was there was an earlier part of the graph in which it was going down. Okay? So it was really looked like a return to normal.
So in the beginning of the graph from 1970 to 1980, is that what you're saying?
Yep.
It's going down?
Yep.
Do you have an image of that?
I think I do, actually. Hang on. Let me.
And so what they were looking at, again, we were talking about how we're measuring things on these very small increments where time for us is 100 years. It's our lifetime. So we're looking at things like as if that's a lot of time.
That's right. And there are these long-term trends, as you saw in the Egyptian river. Can we pull up chart number 35 in the unsettled file?
And we can safely assume that in those long-term trends in the Egyptian data that you're not talking about human influence because it's too long
No,
ago.
it's much too long. Yeah, right. Okay. So let's pull up chart 35 and then, so there is the original graph in the government report from 2014, and what's shown is from 1980 to 2010, and it's going up, right?
Right, but if you see from 19, looks like
Well,
1979.
so let's look at the whole record, which is the next picture. There it is. All right.
So it's real similar to the Egyptian data. That it's up and down.
It's
and
up and down. Now, there's a lot of controversy still. This was 10 years ago or so. There's a lot of controversy about whether storms are getting more intense, One paper says yes, another paper published in July says no, and so on. So the matter is kind of unsettled at the moment, but overall, as I can read for you, the official report, the official statement from the most recent UN report, let me just get it, there is low confidence in most reported long-term, multi-decadal to centennial trends in tropical cyclone, that's hurricanes, frequency or intensity-based metrics.
Now that image, Jamie, can you pull it up again, please?
Yep.
That image, when you see 1975 and then you see 2005, it's not that much of a difference. So the peak of 1945, the peak of 1945, and then you go to 2005, you're not looking at that much of a difference.
Right.
And clearly there's been a gigantic difference in the amount of human influence.
Of course. Let me show you another one, all right? Can we go to chart 3 of the other file? And this is one I think I'm going to go public with pretty soon in an op-ed. Let's put it up. This is about Greenland, okay? And the popular image that Greenland is melting, and it's melting faster and faster and so on, all right? This is the official data set for how much ice Greenland is losing every year. Okay? And it goes up right until 2021, and it starts in 1900. And what's interesting about this, there are several things. First of all, even though human warming influences have been growing steadily over the course of this, there are a lot of ups and downs. So it says it's got to be a lot more than greenhouse gases at play here. The second thing to notice is that in the most recent decades, at the right-hand end of the chart, Greenland is actually starting to melt less rapidly than more rapidly, even as the globe has been warming.
And this is from 2010 to 2020.
Yeah, correct. And then if you go back to 1930, you can see it was melting just as rapidly in 1930 as it was in the last decade or two. And the human influences were less than a fifth of what they are today in 1930.
So what are the other influences if they're not
That's
just...
an excellent question. And the answer is this has got to do a lot with the long-term money-decade cycles of ocean currents and winds in the North Atlantic. And you can find papers that say that. All right, they're research papers, but you don't hear any of that from the official reports or the media.
So the different factors that play into what we think the different factors are that play into the melting is greenhouse gases.
Warming, yes, warming.
Warming, and what are the other ones?
The others are ocean currents that have their own dynamics that are not, just getting warmer. They get warmer and colder. And the weather, if you like, because how much ice Greenland loses every year is a balance between how much snow accumulates, that's the weather, and how much flows out from the glaciers.
Those are the only factors?
Basically. There's a little bit of melting and so on that you have to worry about. But those ups and downs are really weather.
Does anything have to do with where the sun aligns with the Earth and the precession of the equinoxes?
No, that's much too slow. I mean, over this period, year by year, it certainly has a seasonal effect. These are, though, annual values, so they average out the seasons. But, of course, the ice grows in the winter, and then it melts in the summertime.
So there's all this data that shows the ups and the downs, and there's all this data that shows that sometimes they're losing ice, and sometimes they're losing less ice and gaining ice. Yeah. Like, how do they know what is causing this, or do they just assume that there's this series of factors?
They don't. Okay, it is. It's a combination of modeling and physical principles and other data that let them try to say how much is natural variability and how much is human influence. There's no doubt that if the globe keeps warming, that warming might eventually come to dominate the ice loss, the melting. But right now and for the foreseeable many decades, it is these natural variabilities. And instead, in the media, all you hear is that it's been melting faster and faster over the last 2 decades.
And this media narrative, do you think this is just one of those things where people gravitate towards the most alarmist perspective, so that's the one that makes the headline? Is it because of the green energy industry? That
It's all of the above, but I put a lot of it on activist reporters. So this statement that Greenland was melting just as fast in the 1930s as it is today, I made that. I got fact-checked by a reporter, John Greenberg at PolitiFact, and he deemed the statement mostly false. Okay, and you can look at how he analyzed things. He talked to some experts. It's entirely misleading. Right? So I got a non-expert reporter with an agenda and a platform criticizing what's actually in the data.
So the non-expert reporter with an agenda, in order for him to print something that's going to get the response that he's looking for. He's looking for a positive response from the people that are climate, that believe these models and that think that the climate is of utmost importance.
And we're headed for catastrophe.
Yes, catastrophe. And this is the narrative that that's the only thing I've ever heard.
Yeah.
Until I read your book, that's all I had ever heard.
Well, that's interesting. The most recent UN report, okay, which is 3,949 pages, almost 4,000 pages. It took several hundred scientists a couple of years to write. You can search that report for the words existential threat, climate catastrophe, and so on. You find the words climate crisis once in that report, no other alarmist words. And the context for climate crisis is not a scientific finding, but a description of how the U.S. media have overhyped the situation.
Did this start with, I remember global warming in the 80s, because I'm a stand-up comic, and there was comics that would do jokes about global warming, like this is great, I can go golfing in January. They were joking around about it. But then I remember An Inconvenient Truth. And Al Gore put this documentary out when he was vice president, I believe.
No, I
or
think
just was retired.
just before or just after, I can't remember.
And when he put this documentary out, it scared a lot of people.
Yeah.
But there was a lot of predictions in that documentary. Did any of those come true?
Apart from the fact that the globe is going to continue to warm and sea levels are going to rise, and we can talk about that in a bit, most of the predictions, that hurricanes are going to get more intense, or we're going to see more droughts or floods and so on, almost all of the high-impact things don't show any long-term trend. They're all within natural variability.
One of the things that you point out in your book that I found was interesting that I hadn't considered is when they're talking about the amount of damage that hurricanes do. So when they're thinking about what kind of danger there is to hurricanes, they also talk about the economic danger of these hurricanes and the damage that they do. But that damage is accentuated by the fact that the population is increased in these areas. So naturally, when a hurricane hits, there's going to be more things there to
You're going
damage.
to see billions and billions of dollars just because there's more stuff there, okay?
Right.
And more people. All right?
But that doesn't necessarily mean the energy of the hurricane is greater, or that the energy of the hurricanes over time is greater.
No. We can put up, if you want to see some of the hurricane statistics, but that's essentially right.
But the hurricane, sorry to interrupt, but the hurricane thing is not settled. You were saying that.
Right. There's some indication with a paper published a year and a half ago that the strongest storms are becoming more common. But then there was another paper that said, no, it's just a natural fluctuation. So I think that's unsettled yet.
So how do they come to these conclusions that are different?
Yeah.
If they're basing it on data.
Because they're looking at two different kinds of data. The paper published in 2020 looked at satellite images of the hurricanes. We see beautiful images of the hurricanes, and you can try to infer from that how strong the storms are. Okay? They used a new technique. The people who said, no, it's a natural fluctuation, looked in the North Atlantic, where only 10% of the world's hurricanes happen, or 12%, something like that. And they looked at historical records. And so there's an issue that as you go back in time, you haven't seen all of the hurricanes, and you got to correct the observations for that. So they tried to do a good job. What they found was that the measure of hurricane intensity went down from about 1960 to 1980, and then from 1980 to the 2000s was just coming back to normal.
So
So there's a lot of, there's a lot of controversy about this. This is at the bleeding edge of unsettled science.
this variability when it comes to the temperature of the ocean, when it comes to the melting of the ice caps, and all these different things that we're talking about, why does that exist in these radical ups and downs throughout the history of the Earth?
But, the Earth, there are two reasons. One is that the Earth is subject to external influences or influences outside of the climate. The orbit of the Earth around the sun, the way the sunlight falls on the Earth, this is what drives the ice ages, if you like, or the glaciations and so on. But the other is that climate is a chaotic system, which means it has very complicated and variable internal motions, all on its own. We know that because we have cartoons of the equations, and they show that. We know that because you can't predict weather past about 10 days, 2 weeks. It's chaotic, and so it has a lot of variability. Some of these long-term variations we understand. For example, El Nino happens every few years, takes a couple years. We kind of understand that. But these longer-term things that take 70 years, or in some cases 1,000 years, having to do with the motion of the ocean currents, we don't have a very good handle on it all. And part of the problem is the models don't reproduce those well. And so you don't know where you are in those cycles when you're trying to match the model with the observations.
So is it safe to say that what people are looking for, or what people would like to see, is sort of a flat, easily predictable rise and lower, like that there's very little variation.
Right.
And
Yeah.
that this is just not consistent with the historical record?
Absolutely. I'm going to do another one for you. We haven't talked about sea level yet. Can we pull up chart 13 of the Coonan file? So sea level is one of the things that people worry about
Yes.
most, right? And
We're going to lose Miami.
you're going to lose Miami, right? So here's a chart. I live in Manhattan some fraction of the time, and so I've gotten very interested in sea level at the Battery, which is the tip of Manhattan. And there has been a tide gauge there since about 1850 or 1860. And it measures the height of the ocean. It got to average out over the tides and the waves and the weather and so on, but okay. That black line on the graph from 1920 to 2020 is 100 years of actual data showing how fast the sea level is rising. And what you can see is it goes up and down in a cycle, kind of like the Greenland thing we looked at. Mm-hmm. And, the peak was in 1950, and it was up at 5 millimeters a year. We can talk about what that means in a second. And then in 1980, it was down in 2 millimeters a year, and now again it's up at 4 millimeters a year, and looks like it's headed down.
And the peak that you're looking at from the 1950s and 2020 is essentially the same height.
That's right. And, to set a scale, 3 millimeters a year, which is kind of the average over that time, is a foot a century. Okay? 1 foot rise a century, which is about what we've seen over the last 150 years. Okay? It's thought that those ups and downs are due to natural variations in the ocean currents, happening on these long time scales, 70, 80 years. What's interesting is those colored graphs going out from the present to 2000 show that the expected rate of rise starts at about 8 millimeters a year, twice as much as we've ever seen, and then goes on up from there. Okay, those are the UN projections of
Based on
models. Okay, and you can see there are large uncertainties and large variations. I think, if it's going to look like that, we're going to know pretty soon, within the next 10 or 15 years. And my bet is it's just going to go down again.
So why did they have these predictions that are so extreme?
I don't know. You should ask them. Okay? They don't even match up with what's happening today.
No.
All right?
They're much more extreme.
Yeah.
If you're looking at those green lines and the blue lines, much more extreme
Yeah.
than anything that we've seen over 100 years.
And, this is part of why I think we need a really rigorous review of these allegedly authoritative reports.
As a scientist, how frustrating is it when ideology and dogmatic thinking, and when someone's trying to push a narrative and it gets involved in something that is a very complex science with many, many variables, some of them that aren't totally understood in terms of their effect?
Yeah. It's very frustrating to talk to non-experts about this, but I'm even more frustrated with my scientific colleagues, okay, because many of them know that there are these problems in communication, and they do nothing about it, or in fact, they abet it.
They abet it.
Yeah.
Now, and many of them, like you said, who will talk to you privately, will not speak about it publicly for fear of retribution.
Yeah, exactly. One of the reasons I wrote the book was in part to inform people, not persuade them, but also to inform my fellow scientists who are not climate scientists about the kind of misrepresentation that's going on. And many of them have written to me privately or spoken with me and have said, Steve, thanks for doing that.
Thanks for doing that, but I have to shut my mouth.
Yeah, I don't dare speak out about this.
Has it been a problem for you in your career writing this book?
No, I have enough other parts of my life that are interesting and robust. I'm far enough along in my career that, frankly, I don't really care very much at this point what people think of me. I've got enough stature. I have been advising the government on non-climate matters for a long time. I helped guide the national academies in some of the reports they did. To Jason, I advise companies. It's fine. I really just want to get people to understand. Climate literacy and energy literacy, we haven't talked yet much about energy, are so important, and people need to understand. Let me give you an example of a different field that I think is a terrible example. So there's this guy named Jonathan Gruber, who's a professor of economics at MIT. And he was one of the principal architects of the Affordable Care Act, Obamacare. Okay? Now, whatever you might think about Obamacare, what he said at one point was the only way we could get a principal provision of that act passed was to rely on the basic ignorance of the American people.
Wow.
All right? And, there's a videotape of him saying this at a conference.
Crazy thing to say.
And, for an educator and for an advisor
Right.
to say that is terrible. By overhyping the climate threat, we've taken away from non-experts the ability to make their own judgments. We have displaced other priorities, and we've got so many priorities that are beyond climate. We have scared the bejesus out of young people, right? You talk to young people and they think the world is going to end.
Yeah.
And so, that's one of the reasons I wrote the book, is to just try to get people to understand.
Did you see that woman? I believe it was in Canada, but they listed her cause of death as climate change.
No, I've not seen that.
You haven't seen that?
No, but I'm not surprised.
You need to see that, because the first time I saw that, I was like, oh my God, here it comes.
Yeah.
Because, and then, I should say, before I read your book, I was fairly convinced that we're in for a horrible next 50 years of climate change and rise of sea level, and I was buying all of the catastrophic. I bought it all, and then Peter Attia turned me on to your book.
Yep.
I started reading it. I started listening to it rather, and I was just like, okay, this guy, I need to talk to him.
Yeah.
I need to find out what's going on. Let me see if you can find that. Have you found the article?
Yeah,
No one can hear you.
trying to confirm its accuracy. Because when I Googled it, it wasn't coming up a lot of places. I had to
I told you, duck, duck, go, son.
Okay, when I looked
Get
on
up.
the internet for it. It was coming up only in one very specific spot, so I'm trying to find out like
Is
why.
it a bad source?
It's an interesting source. So I'm just trying to see like.
Got it.
Right. When you find it, I want to talk about economic impact a little bit because that's another interesting story.
Yeah. And there's a lot of factors that lead to a narrative being established. What year do you think? Is there a time you can pinpoint when this sort of alarmist perspective really took root?
Yeah, I think it was the early 90s, and it was in part the first UN assessment report that said maybe, we're influencing it. And then there was a subsequent report maybe a decade later that said there was a discernible human impact on the climate. Al Gore's movie, I think the Obama administration pushed pretty hard. And now you've got the Biden administration trying to infuse climate and energy in all sorts of government and private sector activities. There we go. Right?
Here it
That
is.
a decent
Oh,
source.
come on.
Doctor reveals why he wrote climate change on patient's medical chart. When a Canadian doctor wrote 2 words on a medical chart, he had no idea those few strokes of his pen would make global headlines. Climate change is what Dr. Kyle Merritt wrote alongside a patient's symptoms following a heat wave, which resulted in poor air quality across Nelson, British Columbia in late June. Extreme weather condition during the North American summer, the general practitioner believed had deteriorated the health of a 70-year-old woman who was suffering from diabetes and heart failure while living in a caravan with no air conditioning. The idea that you would say that's climate change.
Yeah.
I'm going to read that again. Yeah. A 70-year-old woman who's suffering from diabetes and heart failure while living in a caravan with no air conditioning. So she's in a trailer. She's got diabetes, and she's suffering from heart failure. Right. And they said, climate change.
Right.
And they put that on our autopsy.
Not only that medicine, but the fact of taking one summer heat wave and calling it climate when it's really weather is, displays the ignorance of that doctor.
But it's also in vogue.
Of
right?
course.
And that's...
Who doesn't want to be in vogue?
Yeah, who doesn't want to hop on the trend? I'm sure you got a nice pat on the back.
Oh, sure.
Congratulations.
And of course,
to add in for the
I get all
clarity.
kinds of...
What's that?
It was added on the chart, not her diagnosis, according to him when asked.
Okay, it says, reflecting on the decision, Dr. Merritt said he wasn't trying to make a big deal out of it, but he felt it was important for both him and his colleagues to recognize the truth, in quotes, and add the contributive factor of climate change. But he doesn't really know what he's talking about.
Of course he doesn't. And let's look at the data. Can we pull up chart 7 of the... I'm going to show you something about that heat wave. That's of the Kunin thumbs. No, it's the other
I know.
file.
When I looked this up, though, just for clarity too, this is what when I looked up the battery sea level trends. This is what pops up on the government's website.
So that
shows the trend.
That's the sea level itself, not the shorter term trends. But you can see in the upper right, it shows it's going up at 2.88 millimeters a year, just about 3 millimeters a year for the last 160 years.
So, so I'm confused here now because in that other chart it showed that the levels in what was it 1940?
Yeah. So that's the slope of the other chart that we've been looking at, the shorter term trend. In other words, you can see like from 1930 to 1940, this level is going up more rapidly, right?
Right.
So that black line I showed you on my chart is the trend. How fast it's going up at any given time.
That's kind of deceptive then, right? It's hard to look because what I'm looking at that chart, I thought that was the actual level of the sea.
No, it's not the level. No, it's how fast it's going up.
Oh, okay. Okay,
But
so go back to the other one, Jamie, that you pulled up, and thank you
Yeah.
for doing that.
Yeah.
This is, so this shows a rise.
A rise.
In sea level.
Sea level's been rising for 10,000 years, okay?
How much?
Well, it's got up 120 meters in 20,000 or 10,000 years. That's 500 feet.
500 feet.
400 feet.
400 feet in 10,000 years. And how much over the measurable time that we've been paying attention?
So can we pull up chart 11 in my file? And I'll show you that. There it is. So this is determined from geology. And you can see we started 20,000 years ago, and to the present, it's gone up about 120.
So a
meters.
lot of this is post-ice age.
That's right. The glaciers were melting.
Right.
They started melting 20,000 years ago. And what's interesting is that about 8,000 years ago, things slowed down a lot, as you can see.
Yeah.
Okay.
It
and
flattens
so
out.
it flattens out. It's not completely flat. The real issue is not whether sea level is rising. As you can see, it's been rising for 20,000 years. The real issue is how fast is it rising and whether human influences are making it rise faster. Right. And that's what I showed you in the...
Now, how do they measure? Like when they look at the percentage of like how much agriculture has an impact, how much methane has an impact, how much transportation has an impact. How do they measure all that?
Well, it's complicated. The first question you can ask is how much carbon dioxide is the burning of fossil fuels putting up into the atmosphere? And we can pretty well measure that. We know how much coal is consumed, how much oil, how much natural gas. Methane is harder because most of the methane that comes out is not from fossil fuels.
It's from cow burps,
It's
right?
from cow burps, rice paddies, wastewater treatment, and so on. Okay? And of course, if we're going to reduce those emissions, we have a much more difficult task than just stopping to burn natural gas.
So what are the percentages when it comes to greenhouse gases? Like, say, what's the biggest contributor?
Yeah, so CO2 is the biggest and most problematic contributor because it lasts in the atmosphere a long time, centuries by some measures. Methane is much less problematic, even though it has an impact about half of CO2 currently, because it only lives for about 12 years.
So CO2 is the most significant, but is it also the most abundant?
Yes, but you shouldn't talk about abundance because there are very complicated issues about how the greenhouse gases actually trap the heat in the atmosphere. What you really want to talk about is their contributions to what's called radiative forcing, which is basically how much they enhance the heat intercepting ability of the atmosphere.
So the thing that we talk about when we talk about human impact on climate is CO2
That's correct. And methane.
and methane.
But also, there are a couple of other minor gases like nitrous oxide and CFCs, but humans also exert a cooling influence on the climate.
How so?
Because when we burn dirty coal, we make aerosols, smog, and so on that
Block out the sun.
block out the sun a little bit. And they knock off about half of what CO2 warms. And if we stop burning dirty coal, which we should for other reasons, we're going to see the globe get even warmer than we might otherwise.
How much of an impact does the burning of coal have to cool the earth?
So as I said, it's about half the warming impact of CO2.
Half the warming. Okay, so so the biggest contributor in terms of greenhouse gases, what industry causes the biggest?
Power,
Power.
electrical power generation is big. Heat of various kinds, both for buildings, but also for industrial processes, the next biggest contributor. Transportation, which is what we usually think of in this country as greenhouse gases, globally is only 14% of greenhouse gases.
Now, does that vary by country?
Oh,
to country,
absolutely.
Depending upon the regulations?
Oh, yeah. If you go to China and India, it's mostly electrical power. In the U.S., about 40% of our emissions are transportation.
40%?
Yeah.
Interesting.
Yeah, but the U.S. as a whole is only about 6 billion tons of CO2 a year, whereas the globe as a whole is about 50. Not CO2, of greenhouse gases generally. U.S. is about 8%, something like that. No, more than that. Let's see, it's about 6 out of 50, so 12%.
So then we have transportation.
Yep.
So we have transportation in terms of moving goods and services.
Yeah, burning gasoline and diesel.
And then what's below that?
Electrical power.
Electrical
in the
power.
U.S., electrical power.
And what is that? Coal? Like what is
coal and gas?
Okay.
All right. Wind and solar don't contribute directly to greenhouse gas emissions.
Nor does nuclear, right?
No, nuclear certainly doesn't either, right?
And then what's after that?
Small potatoes,
Okay.
probably home heating and industrial heat. But the big ones are power, transportation, and Agriculture. And globally, I don't know the U.S. number, but globally, agriculture is 25% of greenhouse gas emissions.
Wow.
Right?
And this includes animal agriculture and also monocrop agriculture in terms of like growing.
Yeah, well, fertilizer production, but also rice paddies and wastewater treatments.
Okay.
Okay, those bacteria that produce methane, that's how you treat wastewater, and yeah.
So when talking about these various factors and how they impact the environment, how much into consideration does one have to take? Like, what's the economic impact of making a radical change?
Yeah.
That's like, say, one of the things that keeps coming up is electric cars.
Right.
California has initiated a new law that I believe it's somewhere in the 2030s, right? They can no longer sell gasoline vehicles,
Right.
which is really soon.
Yes, I know. So let's talk about economic impacts. Let me first talk about the economic impact of a changing climate, okay? And then we'll talk about the economic impact of an energy transition, all right? So could we put up chart 21 of the Coonan file? And I'm going to show you a chart that comes right out of the most recent government report on the subject, which is on the left. And what you see is the horizontal scale is how much the temperature would go up at the end of the century compared to what it is today. And, it goes up between 1 and 10 degrees or 15 degrees Fahrenheit. It's a U.S. chart, so it's in Fahrenheit, not centigrade. And what's shown on the vertical axis is the percent of damage to the U.S. economy in 2100. Okay? And the takeaway from this is, first of all, as the temperature rise goes up, the damages go up. But more importantly, for temperature rises of up to 5 degrees centigrade or 9 degrees Fahrenheit, it's 4% of the U.S. economy in 2100. Okay?
I'm not exactly sure what that means.
That means that the economy, if the temperature were to go up, the economy would be 4% smaller in 2100 than it would have been otherwise.
Now, does that take into account the growth of the economy overall?
Well, it's a relative statement.
Okay.
So if we go to the next chart, that's a wonderful question. There's what would happen. So I'll show you the U.S. economy starting from 2000 up to the end of the century. If it grows at 2% a year, which is kind of what everybody thinks it should be doing and might do, you get that curve. If you assume a 4% impact at the end of the century, or even a 10% impact, you just delay the growth by 2 years or a few years in 2100, 80 years from now, all right? So this is not the climate crisis, okay? The economic impact is projected to be minimal.
And this is the economic impact of as the way things stand today, without any major interventions in terms.
That's correct. Well, it's done as depending upon how much warmer the globe gets.
Right.
Okay. So remember, the Paris Agreement is trying to hold things to 2 degrees centigrade or about 4 degrees Fahrenheit, which is a few percent damage to the economy. Okay? In 2100.
Yes.
Okay. Whereas the economy is going to grow by 2% a year. All right, so instead of 70 or 80 years from now, it being, let's say 400, the U.S. economy, instead of being $80 trillion, it would be $76 trillion or something like that in 2100.
That seems like a lot of money.
Well, not as a percentage.
Right.
It grows by 2% a year,
Right.
so it's a 2-year delay in the growth.
2-year delay in the growth.
Okay.
And now, if major policy changes are implemented that are going to shift like the sales of the combustion vehicles being banned, which is what they're doing in California.
Yep.
Did that pass in California? Do you know?
I think that is the current policy in
I
California.
believe it's 2035.
Right,
Is
and,
that what it is?
and you know,
I was looking that up when we started. I was
and the
trying to
federal
see.
government is pushing for the same policy nationwide.
Nationwide.
Yeah.
Now, is there enough of these minerals
Yeah.
that make batteries to?
So what we forget, for people who don't understand energy, want to change the energy system, is that it is a system. And so let's talk about cars, okay? You have to change the car itself, which leads to issues about do you have enough minerals. You have to change the fueling infrastructure, namely, do we have enough charging points? And can the grid handle all these cars plugged in at once? And then you have to change the fuel, or at least provide more electricity to power the cars, in addition to what you're doing now. And oh, by the way, they want to electrify heat as well in the houses. So the grid
Really?
is, yeah. All right.
So here, Governor Newsom announced California will phase out gasoline-powered cars, drastically reduce the demand for fossil fuel. California's fight against climate change. Yeah, it's 2035.
Yeah.
So he wants all new passenger vehicles to be zero emission by 2035 and additional measures to eliminate harmful emissions from the transportation sector.
Yeah.
It says there the transportation sector is responsible for more than half of all California's carbon pollution, 80% of smog-forming pollution, and 95% of toxic diesel emissions, all while communities in the Los Angeles Basin and Central Valley see some of the dirtiest and most toxic air in the country.
So you know, this conflates. I mean, it's a wonderful example of the political discussion. First of all, he's making a policy that will go into effect a long time after he's gone, okay, from the political scene. The second is it conflates carbon pollution, and I hate that word because CO2, which is what they're talking about, is essential for plant growth. The more CO2, the more plants grow. All right. So, in that sense, it's not at all.
Is that an inconvenient truth?
Yes, that's and you know the Earth has gotten 40% greener since 1980.
Yeah, I'd heard about that from Randall Carlson.
Yeah,
He explained that to me, and then when I saw it's actually in your book as well.
Yeah.
The thought process of carbon is only that carbon is a negative thing that's put out by human emissions from vehicles.
Yeah.
But it's the fuel of plants.
The fuel of plants. So we can talk about the carbon cycle for a second, but let me continue with Governor Newsom for a moment, okay?
Okay.
I think what is going to happen as people start heading in that direction is that and with other emissions reducing measures, is there's going to be popular pushback. People won't be able to buy the kind of cars that they want or need, actually. They're going to see their electricity rates go up. They're going to see the grid becoming less reliable, certainly a phenomenon you know about here in Texas. And they're going to say, tell me again why we're doing all of this when the U.S. is only 13% of global emissions. We're going to see geopolitical leverage disappear as we rely more on imported oil. It's already happened, that kind of pushback in the UK, where the government tried to mandate heat pumps in the houses. It would have been about £15,000 per house. And people, the legislature just said, hell no, we're not going to do this. And I believe that that's what's going to happen in this country because they're pushing too far and too fast. I like to say you need to change the energy system not by tooth extraction, but by orthodonture. Slow, steady changes.
Is it possible that battery technology will shift so radically that our concept of what's required to create a battery, specifically the type of conflict minerals and very rare earth minerals that we need right now currently, that would shift by 2035?
No, people are doing a lot of research on batteries. I think that's one of the fields we should be researching more, but it's not as though people haven't been trying. All right. And, there are issues not only with the minerals you use, but the lifetime of the batteries because they get charged and discharged, and that does mayhem at the molecular level that tries to destroy the structure. There's also the weight and size of the battery. And there are many things that go into making a good, viable battery. I think we will see slow, steady progress, but I'm not optimistic that there will be great breakthroughs. People have been trying this for a long time.
But there's no great breakthroughs on the horizon or concepts that may lead to some sort of new technology.
You hear people saying, well, we can produce a battery that's 50% better, but
that's not enough.
That's not enough. And what I've learned is that while things might look really promising in the lab, to actually get them out at scale in the real world is a long, difficult job that you often fail at.
Have they done an analysis on all the rare earth minerals and what the quantities are and what would be required to make all the vehicles on Earth electric?
I'm sure somebody has done those numbers. I don't have them at my fingertips.
Is it possible?
Yeah, so let me tell you about resource, okay? Whether it's minerals or oil or gas and so on. The amount that you can get out depends upon the cost to get it out. And that depends upon the technology as well as how much is there. And so as the price goes up, you're willing to consider more extreme technology, which might cost more, but you can still produce it. Oil's a wonderful example. At $20 a barrel, there are very few ways to produce oil. But at $80 or $90 a barrel, which we're at today, then offshore production, shale, many other technologies become economically viable. And so you shouldn't think about, are we going to run out? But are we going to be able to open up new resources with new technologies fast enough in order to be able to satisfy the demand?
Okay. So you can't just look at it in terms of what you want to see. You have to look at it in terms of there's a lot of factors.
Yes. So, nobody has put together a sensible decarbonization plan for the U.S., let alone the globe. A sensible plan would entail technology, economics, business, because people have to make money doing this. It would entail what are the right policies and regulations, and it would also entail consumer behavior and preference. The plans that are put out by the National Academy, by universities, are generally formulated by, if you'll excuse me, a bunch of academics, okay? And I can say that because I used to be one and I still am, okay? But very few people who have experience with the real energy system of having to create and operate, whether it's fueling or electrical power and so on. So I think the best thing that can be done right now is to get that kind of group together, spend a while, we've got the time, and let's come up with something that will let us decarbonize in a graceful way rather than the kind of very disruptive things that are being proposed now.
We were looking at this proposal for an enormous machine that was like the size of a skyscraper. Have you seen this?
No. Tell me, what does the machine do?
The idea was that this machine extracts carbon and particulates from the atmosphere, so it reduces pollution.
Yes. So there are a number of people working on that. It's called direct air capture. And the question is, can you do it cheaply enough per ton? And can you do it at scale, namely to do enough of it to make a material difference in how much carbon dioxide there is in the atmosphere? Right now, it's about $500 a ton of CO2 to extract it from the atmosphere.
How much is CO2 worth?
Yes, well,
per ton?
Unless the government intervenes, it's not worth anything. But if you look at the right question, I think, to ask is, what does the price need to be to start to shift the power sector away from coal? And the answer is about $40 a ton or $50 a ton. Okay, so people who are trying to do this hope to bring that $500 a ton down to $100 a ton. Still too expensive. But if the price of carbon goes up to $100 a ton, then you can start to make money. But then the real question is, can you do this at scale? Right? And there I'm very doubtful. You need to suck out 10 billion tons a year of CO2. And to think about how much atmosphere you need to pass through this machine with the capture efficiency you have and so on, nah. If you want to capture CO2, the best way to do it is to plant trees.
Really?
Yeah. So a little bit about the carbon cycle. All right?
Okay,
it's real interesting. When I was a kid, I hated earth science because you had to know too much. All right, I like math, physics, because you don't need to know much. You just need to be clever. But as I've gotten older, you start to realize these things are just wonderful science. So about 200 billion tons of carbon, so roughly 800 billion tons of CO2, go up and back between the atmosphere and the Earth's surface every year, more or less in balance. 800 billion up, 800 billion down, having to do with the seasonal cycle of plant growth and changes in ocean temperature and so on. So 200 billion tons of carbon is a good number to remember. We are digging out of the ground about 9 billion tons of carbon every year in the form of oil, gas, and coal, and burning some forest as well, and putting it up into the atmosphere, into this cycle. And it's gradually going up. About half of it stays in the atmosphere every year. Okay? So if you could tweak that big cycle of 200 every year by a little bit, you could compensate in part or perhaps in whole for those 9 billion tons that we're putting in every year. And the way to do that is to grow more trees or other living things, because they suck carbon out of the atmosphere to make what they to make plant material.
And when you pointed this out in your book, you were talking about the study of green leaves and the percentage of green leaves. This is all gotten through satellite imagery?
Yes. So we can measure what's called, well, not only the color, but what's called the leaf area index, which is the fraction of the land covered by leaves in any particular place. Of course, it's really high in the Amazon. It's pretty low in the Sahara or the Southwest. And we can watch that over the years, and we've been watching it for 40, 50, 60 years. And it's gone up, as I said, by about 40% globally. The world is getting greener because there's more CO2.
That's inconvenient because we don't want to think about it that way. We want to think everything's catching on fire and it's all brown and there's no more water. And
right. You know, crop yields have been going up steadily since 1960. A lot of that is agronomy, that we've gotten better at farming, we've gotten better genetic strains of plants, but some of it also is more CO2. Plants love CO2. We put CO2 into greenhouses to get them to grow more. They also love warmer temperatures and longer growing seasons. So, for example, I don't like to cite, this year, et cetera, but I will in this case. India has seen record grain harvests this year, more than any other year. And long-term over the world, the yields have been going up. Okay? Because it's getting warmer, we're getting better at agronomy, and there's more CO2.
Now, is there a point of diminishing returns? Like, is there a point where there's so much CO2 in the atmosphere that then it becomes detrimental?
Yes. So there's a lot of controversy about that. Some people say, eventually you're going to be limited by water or nutrients in the soil, but we haven't seen it yet.
We haven't seen it yet.
Yeah.
So these factors that lead to climate change, the human contributions of agriculture, transportation, all the various ones that you discussed earlier, how much of that can be eliminated?
At what cost? All right? And here I want to take a global view, okay? We in the U.S. have a very distorted view of the world. We're a big country. Many people don't travel. They have no sense of what's going on in the rest of the world. In the developed world, the U.S., Europe, Japan, Australia, Canada, and so on, about 1.5 billion people. And we have high energy use, and we have a pretty good standard of living. There are 6 billion other people in the world who need energy in order to improve their economic lot. 1-point-something billion people in China, another 1-point-something billion people in India, and so on. The best way for them to get their energy in terms of reliability and convenience is fossil fuels. And who are we to tell them, no, you can't do that? That's a moral issue, as Alex Epstein, for example, has pointed out. And so when you say, can we reduce and what's it going to cost, I think you have to distinguish between those of us in the developed world where we can do it. We can cut our emissions if we have enough financial capital and political capital to do it. But what are you going to do about the people in Indonesia, China, India who need the energy? What do you tell them? And nobody has a good answer for that.
So we're looking at it from perspective of this first world country, and we're not taking into consideration that there's a lot of countries, particularly third world countries, that are already struggling. And if we implemented these radical restrictions, it would devastate their economy.
Well, we can't implement restrictions
Right.
on them. We can implement restrictions on ourselves, which will come at some cost and benefit, minimal benefit. We're only 13 in the U.S., 13% of emissions, right?
Now, when we look at all of these factors, agriculture, transportation, all these different things, if you eliminated that, how much of an impact would that have on overall climate change and, warming?
Yeah. So you want to do that for the world as a whole or just for the U.S.?
Let's just do it for the U.S.
Yeah, so we're 13% of emissions. What you need to understand is that emissions accumulate in the atmosphere. And so by eliminating U.S. emissions, you have only slowed down the rate at which the amount in the atmosphere accumulates.
When you say we're 13% globally?
Globally, correct. Correct. So the rest of the world, the emissions are growing because they're burning coal and they're burning oil and gas because they need all that. All right? So our 13% decrease, if we could do it tomorrow, would be wiped out by about a decade's worth of growth in the rest of the world.
So the growth in the rest of the world, they would just contribute so much that it wouldn't matter what we take
That's
out.
right. And
so they're
yes.
growing and their economies are booming. And
Who's going to tell them you shouldn't do that?
Right.
All right. I like to say, they've got the wolf at the door. All right. A real immediate problem with they need lighting, refrigeration, transportation, and so on. And they're not going to worry about their cholesterol, the long term, what's going to happen 2 generations from now, and it's kind of vague, and who knows exactly what's going to happen. So they are making what I would think is actually a pretty sensible solution for a sensible course of action from their point of view.
Let's say if that didn't happen. Let's say if the rest of the world stayed static, exactly how it sits now. What we do, if we could, what is possible to do to eliminate our impact?
Yeah, if the rest of the world stayed static, our influences would still continue. Global influences would continue to grow because they keep emitting and it keeps accumulating. Even if they're not emitting anymore in the future, they're still emitting and it's accumulating. If we wanted to just stabilize human influences, not let them grow, we would have to go to net zero, namely zero emissions overall, by 2050, 30 years from now, if we wanted to stabilize at a 1.5 degree rise. We'd have to go to zero by 2075 if we wanted to stabilize at 2 degree rise. And if I look at the issues of development, demographics, technology, economics, and so on, I would say both of those goals are fantasy. It's just not going to happen because people need the energy. They need to develop. We in the developed world, in the U.S., might reduce our emissions, but it ain't going to make much difference.
So the proposals that you hear, when you hear about government proposals for addressing climate change, and when you hear about these summits where these countries get together and talk about what they're going to do to implement climate change, how much of that is just sort of signaling that they're working towards doing something good? I mean, they were always criticized for taking private jets to these things in the first place, which is very odd. But what impact could happen from any of these things that they're proposing?
Well, let's talk about what has happened in the past first. We just finished in Glasgow in November, COP26, the 26th annual conference of parties. And during that time, it started 26 years ago, which is probably 1995 or so, greenhouse gas emissions have grown spectacularly, right, despite all of the rhetoric and the treaties, accords, promises, and so on. And the UN itself said that a lot of the pledges that countries have made to reduce their emissions over the next 5 to 10 years are not going to be met, are not being met. Right? So I think it's a lot of politicians talking.
So they're not met, but what if they were?
So we might reduce emissions now from 52 billion tons a year equivalent down to 46 or something like that. It's still a lot. Remember, we got to go to zero in 30 years if you want to stabilize.
But is that real? So if they go to zero in 30 years, what is the actual result?
Well, we will have stabilized, not eliminated, but just prevented from growing human
Change in the climate is human influence.
As we said, that's a subject of some debate right now.
What is the
half maybe of the warming? Okay,
Yeah.
but there's a lot more than warming going on. There are storms and there are most of those are within natural variability.
So in terms of like your 100-year chart of ups and downs, most
Not
of
going
those.
to change that. Not going to change.
So
that.
is it a percentage point?
No, I don't think people have tried to quantify
They haven't.
at that level.
Because it's too complex?
It's too complex. Yeah. And we have limited data. Okay? We don't have 100 years worth of data
Right.
in many variables.
And again, this is what we're talking about at the beginning, that when you're looking at a human lifetime, it's such a short period of time that we look at a shift in our lifetime and you're like, oh my God, the sky is falling.
Yep. Think about the Egyptians in the
Yes,
river, right?
right.
They said, oh my God, the drought's coming. And you just wait another 100 years and it comes back up again. Okay?
Right.
That's not true for everything. Humans are certainly having an influence, but a lot of the variability, the daily weather that the weather people talk about as climate change, it drives me crazy when I hear Al Roker talk about that as climate change.
It's not.
It's not.
It's just the variability and the chaos of weather itself.
Yeah.
And this is for certain based on the models.
Well, it's our best guess. This is an uncertain science. The models are kind of all over the place. And if you had a bet, many of these phenomena are not being influenced by human.
Now, what prominent scientists and climate scientists have arguments against your book and against you and the way you're relaying this information?
So, Michael Mann, for example, Naomi Oreskes, Alan Dressler, Kerry Emanuel at MIT. I'll tell you an interesting story about Kerry in a minute. Have all spoken out and said, Koonens doesn't have it right. Very few of them offer specifics. Kerry did. And I think I have a Medium page that people can look at where I've written detailed rebuttals to the science. I mean, when people say you're a shill for the oil business or you're a physicist, what do you know about climate? I can't answer those, all right? But I can try to rebut the specific facts that they say I've misrepresented, and I do, I think, effectively. Again, you can find it on my Medium page. Sorry about Kerry. So Kerry was one of the people who criticized me early on. He said, anybody who talks about 100-year trends in hurricanes doesn't understand that we only have good data until 80 years. But previously in this conversation, I read you the official statement, which says no long-term trends over a century. All right, so he was being, I think, he's putting on his Cambridge bow tie and saying nobody who understands, et cetera, et cetera. I had the opportunity to share a stage with Kerry at MIT in October, and it was convened by John Deutsch, who's a good friend of both of us and a senior scientific figure. And I had my 10, 15-minute presentation, and I went through some of the things we've talked about. Kerry had 10 or 15 minutes, and he didn't challenge the science at all. I was really surprised. Instead, he started talking about fat tails, namely improbable things that might happen with high consequence, but no disagreement with the science.
So the improbable things with high consequence, this is the sky is falling narrative.
Yeah, so Greenland starts melting,
Yeah.
the permafrost outgasses, the Atlantic circulation slows down, the Amazon dries out, and so
Did you try to press him?
No, I didn't, because I was too polite. He was being too polite.
Interesting.
Yeah, and unfortunately, that exchange was not recorded.
Even
But
more interesting.
Even more. I would love to be on a stage with some of these scientists. Okay.
What about on a podcast? Like,
Oh, yeah,
one of the things
of
that I understand that this is going to be a very controversial podcast, and your book is controversial. I would like to get someone to come on opposite of you next and either by themselves first, and then you with them together, or depending upon what they would like? Maybe.
I would certainly be up for that, but let me tell you what you should do. Have somebody else on, and you can have them say where that guy Coonan is wrong, but then have them write it down, okay? You really, if you're going to do a scientific discussion, debate, you got to put it in writing. Okay? You can't call names, and you can't say, okay? So get them to write it down. I've, of course, written down everything with citations. Get them to write it down, and then get the two of us on together, and let's have a discussion.
Now, I know there's been some articles that have sort of attempted to debunk this. What is the best one that you've seen?
I don't think any of them are really very good. There's a young guy who, I'll get his name wrong, but you can look him up, who's a real climate scientist. And